Okay, so for number 5, we have y equals 100, 1.99 to the t power. Okay, so y is the number of bacteria in thousands. T is the number of hours the culture is incubated. Tell whether the model represents growth or decay. Our base is 1.99. That's bigger than 1, so this would be growth. It says identify the hourly percent increase. Okay, so remember growth, our little equation we learned last week was y equals a, the initial amount, and then growth was 1 plus r to the t power, right? Well, r1 plus r is 1.99. Oops, forgot my equal sign. So what's r equal? 0.99. All right, which percent is 99%, and that's an increase, right? And most of you could have just done that in your head, right? Which is fine. All right, then part C, it says estimate when the number of bacteria will be 1 million. Well, remember, this was in thousands when we started, right? So this 100 we started with was 100,000, remember? So 1 million is how many thousands? 1,000 thousands, right? So when we go to our XY table in our, because we've been doing these on our calculator, right? We're looking for 1,000 here, and then whatever this is our answer. That's how many hours it took, okay? So we're not looking for 1 million in our table. We're looking for 1,000 because it's in 1,000, all right? So that's the tricky part for some of us. So just go to your calculator and put that in your y equals. And it's 100, and then 1.99 to the, we use x instead of t. Now we could put 1,000 here too. We've done it 2 ways. I'll do both ways. We can look at the table, or we can look at the graph and see where the 2 lines intersect, right? All right, let's do the table first. So hit second graph for table. And again, I'm looking in the Y1 column for 1,000. All right. Well, there's 788. And then the next one is, 1,568. So it's between 3 and 4 hours, right? And there's kind of a big jump there. Okay. So we're looking, here's the 788 and here's the 1568. So 1,000 is somewhere in between there. So it's between 3 and 4 hours. So the other way, using the graph, looking at the graph will be, so when we have this, so remember, if we're at our normal Zoom 6 graph, see, I have a different window right now. So let's see if it shows up. I don't know if it will. I don't know what my window is right now. All right, so I have to change my window. All right, so I'm going to go to window. That's right next to the y equals. And we'll just start at 0 hours, and 25 should be fine. 25 hours, and we'll go by ones. And y min, let's start at 100. Oops, not 1,000, sorry. And because that's where we started. And our max is 1,000, so let's go to 2,000 just for, so we can see a little bit. And let's go by hundreds, so we're not looking too bad. And hit the graph. So there's our growth graph. And our line, there's our horizontal line for 1,000. So we're going to look for that point of intersection, and we'll be more accurate than saying we'll get 3 point something hours instead of between 3 and 4 hours here. Okay. So again, I hit window just to get some numbers in there. And again, you can go by whatever increments you want. If you want to go by ones, that's fine too. But here's how we get to the intersection. We hit second trace, and number 5 is intersect. And then all we have to do is hit enter 3 times. And the intersection of those two graphs is, I'll make it a little bigger so you guys can see it. I'm trying to get it under there, but that's all right. We'll just cover up the 3 and 4. All right, 3.35. hours. So that's more accurate. Than the table. Okay. So the tricky part again is figuring out how many thousands is a million and then looking in the right spot. Any questions on that? So that's not very difficult when the calculator does it for us, our graphing calculator, right? All right. In exercise 6 or 7, rewrite the function in the form of a equals 1 plus r to the t or y equals 1 minus r to the t and state the growth. That's not really how I showed you how to do those, right? I told you to do this. Put 3 halves to the 1 over, this case, 7, and figure out what that is, and then put it in. And this is growth because 3 halves is 1.5. It's bigger than 1. So we're going to write 1 plus r equals this answer. All right. So go to our calculator and put 3 halves to the 1/7 power. And see what that is. All right, 1.06 will round it. So then R is 0.06, which would be 6%. And that's an increase, right? That's a growth problem. All right. So that's how I showed you to do it. Make the t, the time 1/7 when we had those fractional exponents, so we can look to see what the increase or decrease is. All right. Number 7 is similar to that. All right. This one, it was 0.9 to the 4t power. All right. So we're going to put a 1 in for t. So this would be 0.9 to the 4 times 1, or 4th power. And this is going to be less than 1 to 0.9. So this is going to be a decay problem. So we're going to go 1 minus r equals that answer. If I can get my, there we go. 0.9 to the 4th is 0.6561. We're going to subtract 1 from that. That's what negative r is. So minus 1. All right, and then when I divide by negative 1, it becomes positive. And we'll just round it negative 0.34. I'm sorry, it's not positive. On negative, it's positive. All right, because we divided by negative 1. So that's decay. And that's 34%, or we could go 0.4%, I guess. Questions on 6 or 7, that type of problem. So what we did when we had different looking exponents, t over 7 or 4 times t, we put 1 in place of the t, so we can figure it out and then write if it's decay, 1 minus r equals that. If it's growth, 1 plus r equals that, so we can figure out our rate of growth or rate of decay. Okay? Any questions? All right. Number 8 is a compound interest formula. Okay. And we learned this formula for compound interest. It was P, the principal, how much you start with, 1 plus the interest rate over the number of times it's compounded in a year to the n times t, the number of years. And again, how many times it's compounded. All right. So we deposited $12.50. So that's our principal, our P value, in an account that pays 1.25% interest. So remember, when we put our R value in there, 1.25 is 0.0125. We move that decimal point 2 places to the left when we plug into the formula. Compounded daily for 5 years. So N is 365 when it's compounded daily. Remember, to the 365, and it was for 5 years. Okay? So that's what we're going to put in our calculator. And Lucas, what'd you get?
640,638.
No. Sorry. Addie. 1,330.62 is what we should get. So, did you have the right numbers, Lucas? Those same numbers I had?
Oh, I had 1.25.
Okay, yeah. So remember to move that decimal point to the left when you put it in the formula. Okay? And that's a common mistake. That's the one we want to make sure we don't make on the quiz Thursday. Okay? Any questions on 8? Okay, let's turn it over. Number 1 says an initial investment of $10,000 grows at 11% per year. Write a function that represents the value of the investment after T years and how much money will be in the account after 15 years. Okay? So this wasn't compound. It didn't say compound interest. So this is the basic one. And I gave you the formula up there. So this was what we started with. And then this was growing. So it's a 1 plus R to the T power. Okay? So we started with $10,000 for this one. And the interest rate was 11% per year, 0.11. And then for T years. All right? So it said, write a function after T years and then how much after 15. So then we're going to put 15 in for T. And Ryder, what'd you get?
It's not right.
You didn't use the right formula? Okay. Make sure when I give you a formula, you guys use it. Brent?
It's 47,845.90.
I got 8.9. You're supposed to go to the nearest cent. Okay, you went to the nearest 10 cents, looks like. All right. So when you're doing money, go to the nearest cent. Be accurate. All right. So again, I gave you that formula. Number 2, a certain bacteria culture increases. So this is just like number 1, right? This is increases of 1 plus R. Okay. So we're going to use the same one that we just did, A or Y. You can use Y or A, like I gave you an A up there, up above. The total amount after T minutes. It said 8 o'clock, there were 5,000 bacteria. And 7.8% per minute, so that's 0.078 per minute, and T for the number of minutes, or X, whatever you want to put there, because we use in our calculator X. Okay. So how many bacteria were present at 8:45? Okay. So remember, this was at 8 a.m. right? So at 8:45, what's the number of minutes? What do I put in for the T? Somebody help me out. Louder. At 8:45, this was at 8 o'clock. How much at 8:45? How much time did we have? 45 minutes. Thank you. Come on, let's wake up. All right. And that answer is 146,829.8. So you want, if you said 830, that's fine. All right. Now, what time were there about 500,000 present? Okay. So that's when you're going to go into your calculator. All right. Put it in your Y equals 5,000. 1 plus 0.078 to the X power. If you want to put 500,000 there, you can. And see the intersection. Okay. And then if I graph it, it won't work right now. So I'm going to go to the window. And our X-Men is, we'll just go 0, 8 o'clock. So 25 minutes. Let's go a couple hours. What's that? 120 minutes? We'll go every 5 minutes just for the, so it won't be so big. And then the Y-Man was 500 or 5,000. And let's go 750,000. And let's go by 5,000. All right. And we'll hit the graph. And there's our growth graph. And then our 500,000 line, there it comes in. All right. So then we're going to go second trace, intersect of those two. So hit 5 and then hit enter 3 times. 1, 2, 3. And the answer is 61.3. All right. And that's minutes. So just 61 minutes is fine. Does it say to the nearest minute? No. So, but if you said 61.3 minutes, did you answer the question? Because it said at what time? So what time was that? 61.3 minutes after we started. What time of day is that? Madison? Yeah, but what time of day did we start? No, we started at 8 a.m. So what's 61 minutes after 8 a.m.? Right. Okay. So you just had to think a little bit there because it asked for, gave you times. So you had to think about how many minutes from when you started. It gives you the information you need. Okay. So make sure you answer questions that are asked of you on the quiz Thursday. All right. The last two were compound interest formulas. I gave you the formula again. Principal, how much you start with, plus interest rate over the number of times it's compounded to the number of times it's compounded times the number of years. All right. So it said Tommy deposited $1,500 in an account. That pays 4% interest, 0.04 when you put it in. Compounded quarterly. How many times a year is that? 4. And it said for 2 years. You're going to put 4 times 2 up there, or you're going to put what number? 8. You guys can do the 4 times 2 in your head, right? So just put to the 8th power. Lydia, what'd you get? $0.29, you said? Yep, that's correct. $1,624.29. So you made $124.29 in 2 years. 4% isn't going to grow real fast, and only quarterly, only compounding 4 times a year. Daily, you get a little more. And remember, these start out kind of flat, and then they take off, right? So if you do it for a lot of years, it's going to get you a lot of money. All right, the Smiths have $12,000 in a savings account. The bank pays them 3.5%. That's 0.035. Compounded monthly. So how many times a year is that? 12. We'll find the total balance after 3 years. So most of you know 12 times 3 is 36. So just put the 36 in. Cole, what'd you get?
13,326.
And 49 cents. So again, those are just formulas we got to plug in and just put the right numbers in the right spots, right? Make sure you put in our calculator correctly. Is this that difficult for you guys? Shouldn't be. I think it's going to be all right. Pretty easy for you. All right. So this quiz is scheduled for Thursday. Some of you are in marketing. Some of you might be in legal studies. If you're not going to be here, you need to get it done before you leave. Okay? Before Thursday, because this is the end of the 9 weeks. Okay? So we got to get it done.